Hello students, today we will discuss new chapter of MSc 2 syllabus, that is vector calculus. So in that chapter first topic is gradient. So the vector differential operator del is denoted by this symbol and is defined as del is equal to I del by del x plus j del by del y plus k del by del z. This is called vector differential operator del. So this will be helpful to define gradient. So gradient of scalar field phi is denoted by this symbol grad phi and is defined as grad phi is equal to I del phi by del x plus j del phi by del y plus k del phi by del z. Basically this is del and we have to find del phi or grad phi. So we have to multiply both sides by phi. So grad phi is given by I del phi by del x plus j del phi by del y plus k del phi by del z. We have multiplied phi both sides. Here you have to note that phi is scalar field. Okay, so gradient of phi is defined by this I del phi by del x plus j del phi by del y plus k del phi by del z. So we can say that gradient is an operator which converts scalar into vector. Here you can see we have applied gradient over the scalar field phi. Phi is a scalar. And what is our answer? Our answer is in terms of vector. So we can say gradient is operator which converts scalar into vector. So grad phi is a vector quantity. Now what is the geometrically importance of gradient? So geometrically gradient of phi represents a vector normal to the surface. Suppose this is one surface, phi x y z is equal to constant. So basically gradient of phi will give us the normal vector to the surface. So in example, suppose they are asking find out the normal vector to given surface. That means we have to find out gradient of phi. So gradient of phi will give us normal vector. Normal vector, that means it will give us perpendicular vector to any surface. Clear? Now let us take some examples. First example, if phi is equal to 3x square y minus y cube z square, then find gradient phi at the point 1 comma minus 2 comma minus 1. So here we have to find gradient phi. So using the formula of gradient phi is given by I del phi by del x plus j del phi by del y plus k del phi by del z. Clear? Now what is phi? Phi is 3x square y minus y cube z square. So putting this function here, so del by del x in bracket 3x square y minus y cube z square plus j del by del y in bracket 3x square y minus y cube z square plus k del by del z in bracket 3x square y minus y cube z square. Now partially differentiating this function with respect to x, we will get 6xy plus, now partially differentiating this function with respect to y, we will get 3x square minus 3y square z square j plus, again partially differentiating with respect to z, we will get minus 2y cube z k. Clear? This is our gradient phi. Now we have to find this gradient phi at the point 1 comma minus 2 comma minus 1. So simply we have to replace x by 1, y by minus 2 and z by minus 1 in this expression. Okay, so we will get gradient phi is equal to 6 into 1 into minus 2 plus 3 minus 3 into 4 into 1 j plus minus 2 minus 8 minus 1 k. Clear? So final answer will be minus 12i minus 9j minus 16k. This is our final answer of this function gradient phi. Now let us study example number 2. Example number 2, find a unit vector normal to the surface x cube plus y cube plus 3xyz is equal to 3 at the point 1 comma 2 comma minus 1. So here we have to find unit vector normal to the surface. Okay, that means we have to find the normal vector and also unit vector. So this is our surface. So consider phi is equal to x cube plus y cube plus 3xyz. That is our surface, because comparing this with the equation phi xyz is equal to constant, then we can say this is our phi. So phi is equal to x cube plus y cube plus 3xyz. Okay. Now we have to find first of all gradient phi, because here we have to find the normal vector to the surface. So normal vector to the surface, that means it is gradient phi. So finding the gradient phi, I del by del x, here phi, plus j del by del y, here again phi, plus k del by del z phi. Clear? So partially differentiating with respect to x, we will get 3x square plus 3yz. Okay. Similarly here partially differentiating with respect to y, then we will get 3y square plus 3xz. Same way here differentiating with respect to z, so we will get 3xy kk. So this is our answer of gradient phi. Now we have to find the gradient phi at this point 1, 2, -1. So replacing x by 1, y by 2 and z by -1 in this expression. Clear? Then after simplification we will get minus 3i plus 9j plus 6k. Clear? So this is our normal vector to the given surface, but we have to find the unit vector normal to given surface. That's why now we will find the unit vector of this. So you know how to find unit vector. So for unit vector, suppose here unit vector is denoted by n cap, that is equal to vector divided by its magnitude. This is the definition of unit vector. So grade phi divided by its magnitude. Clear? So we have already found gradient phi, that is minus 3i plus 9j plus 6k. So written over here, divided by its magnitude, so it is minus 3 whole square plus 9 square plus 6 square and in under root. Clear? So it will be minus 3i plus 9j plus 6k divided by 9 plus 81 plus 36, so it will be under root 126. So this is our final answer of this question. So we have found unit vector normal to the surface. Here you have to note that we have to find the unit vector normal to the surface. If in the question it is written okay, find only normal vector, then your answer will be up to this. Clear? But here we have to find also unit vector. Clear? Unit vector, that's why we have found unit vector of this. Okay. Now let us discuss example number 3, that is if r vector is given by xi plus yj plus zk, then show that del log r is equal to 1 divided by r into r cap, where r cap is unit vector. So here we have to find del log r. So by definition del log r can be written as I del by del x of log r plus j del by del y of log r plus k del by del z of log r. So here we have to find partial derivative of log r with respect to x. So for that we have to differentiate log r with respect to r, then we will differentiate with respect to x. So this term can be expressed as del by del r of log r into del r by del x. So what is del by del r of log r? It will be 1 divided by r. So answer is 1 divided by r into del r by del x. Same way for this term, if we have to find partial derivative of log r with respect to y, then we will have to differentiate log r with respect to r, then with respect to y. So this term can be written as del by del r in bracket log r into del r by del y. So what is del by del r of log r? It is 1 divided by r. So 1 divided by r into del r by del y. Same way, if we have to find partial derivative of log r with respect to z, then we have to express this term as del by del r of log r into del r by del z. So it will be 1 by r into del r by del z. Now we have to find these three terms, del r by del x, del r by del y and del r by del z. So for that r is given by magnitude of given vector, so it will be under root x square plus y square plus z square. Now squaring both sides, we will get r square is equal to x square plus y square plus z square. Now we have to find out first del r by del x. For that partially differentiating both sides with respect to x. So what is differentiation of r square with respect to x? So first of all we will differentiate r square with respect to r, then we will differentiate with respect to x. So this can be written as 2r into del r by del x. Clear? And partial differentiation of x square is 2x. Partial differentiation of y square and z square will be 0. Okay. So final answer will be del x divided by r. Okay. So del r by del x is equal to x divided by r. Similarly, if we have to find del r by del y, then we will partially differentiate both sides with respect to y. So r square can be written as 2r del r by del y is equal to 2y. So del r by del y is equal to y divided by r. Similarly, if we have to find del r by del z, then partially differentiate both sides with respect to z. Then we will get 2r del r by del z is equal to 2z. So del r by del z is equal to z divided by r. Now putting all these values in this expression, we will get, now 1 by r is common from all these three terms, so it will be 1 by r in bracket x divided by ri plus y divided by rj plus z divided by rk. Clear? Now further simplifying, we will get xi plus yj plus zk whole divided by r. Okay. Now this is our given vector, that is r vector. And what is r? It is magnitude of given vector. Clear? Now by the definition of unit vector, we can write down this as a r cap, because unit vector is defined as given vector divided by its magnitude. Okay. So hence we have proved del log r is equal to r cap divided by r. Okay. Now let us discuss topic number 2, that is directional derivative. So first of all, what is directional derivative? Directional derivative is defined as dot product of gradient phi and unit vector in the given direction. So we can say directional derivative is dot product of gradient phi and unit vector in the given direction, where n cap is unit vector in the given direction. Directional derivative is also called derivative with direction. Okay. Now let us discuss first example. Find the directional derivative of function 2x square plus 3y square plus z square at the point 2, 1, 3 in the direction 1, 0, -2. Clear? So if we have to find directional derivative, then first of all we have to find gradient of phi. Clear? So here we have to find the gradient of this function. So grade f is defined as I del f by del x plus j del f by del y plus k del f by del z. So partial differentiation of this function with respect to x will be 4x. So partial derivative of this function with respect to y will be 6y, and with respect to z will be 2z. So final answer is 4xi plus 6yj plus 2zk. Okay. Now we have to find at the point 2, 1, 3. So replace x by 2, y by 1 and z by 3. We will get grade f is equal to 8i plus 6j plus 6k. Okay. So this is final answer of gradient f. But we have to find the directional derivative in the direction 1, 0, -2. So this can be written as 1i plus 0j minus 2k. Okay. So directional derivative in the direction of vector is given by the definition grade f dot a cap. A cap means it is unit vector in the given direction. So it can be expressed as given vector divided by its magnitude. And what is grade f? Grade f is 8i plus 6j plus 6k. Clear? Dot given vector is I minus 2k divided by its magnitude 1 square plus minus 2 whole square in under root. Okay. Now you know how to find dot product of two vectors. So simply a1 b1 plus a2 b2 plus a3 b3. So here a1 is 8, b1 is 1, so 8 into 1, plus here a2 is 6, b2 is 0, so 6 into 0, plus here a3 is 6 and b3 is minus 2, so 6 into minus 2. So final answer 8 minus 12 divided by root 5, so it will be minus 4 divided by root 5. So this is our answer of the question example number 1. Okay, now let us discuss example number 2, that is find the derivative of function at the point 2, 0 in the direction of 3i minus 4j. Here they have written find the derivative in the direction, so indirectly they are asking to find the directional derivative, because directional derivative means derivative with direction. So for that, first of all we have to find grade f. So grade f is given by I del x in bracket x e raised to y plus cos xy plus j del by del y in bracket x e raised to y plus cos xy plus k del by del z in bracket x e raised to y cos xy. So what is partial differentiation of this function with respect to x? It will be e raised to y. Derivative of cos theta is minus sin theta, but here we have to differentiate xy also. So differentiation of xy with respect to x, it will be y, so it is minus y sin xy. Similarly, partial differentiation of this term with respect to y will be x as it is, derivative of e raised to y is e raised to y, derivative of cos theta is minus sin theta, and derivative of xy with respect to y will be x, so it is minus x sin xy. Now differentiating this function with respect to z, it will be 0 because x and y will be constant. Okay, now we have to find this at point 2, 0. So replacing x by 2 and y by 0, we will get e raised to 0 minus 0 I plus 2 e raised to 0 minus 2 sin 0 j. Okay, so it will be I plus 2j. Okay, so this is grade f, but we have to find the directional derivative in the direction this. Okay, so directional derivative is given by dot product of grade f and a cap. So it will be grade f is I plus 2j dot 3i minus 4j divided by its magnitude. Magnitude is under root 9 plus 16. So further simplifying, it will be 3 minus 8 divided by 5. So minus 5 divided by 5. So answer is minus 1. So this is the answer of example number 2. So in this lecture we have studied about gradient and directional derivative. Thank you for watching this video.